In this video we have two integrals to evaluate. Now for the first one we have, the first term here is x e to the 2x. Now this one's going to involve integration by parts. And the second one we could break it up into the integral of x squared dx. That's just a basic integration there. So we have the formula there for integration by parts. That's the general formula. I'm going to look at the first integral first. So it would be the integral of x e to 2x dx. So for that integral I'm going to pick u to be x. That's easy to differentiate. I'm going to let the dv equal to e to the 2x. This will be a dx here. So du would equal to the derivative of x is just 1. So that would be 1 dx or just dx. Now we need the v. So we integrate with respect to v, and the left side here I get v. On the right side with respect to x, and that's going to give me e to the 2x over 2. And we're pretty much set. Now we have to apply this formula here. Equal the integral, then we'll do this one first here. So that's going to be uv. So this is u, this is v. So that'll be x, and then v would be e to the 2x over 2. And that's minus, look at the formula, it's going to be the integral of v, which is e to the 2x over 2, and then du. But du is just that. So this is going to equal to, doing the first one here, still have this x, e to the 2x over 2, and then I have the minus here, and then it's the integral of this. Well, derivative of 2x is 2, so divide by that here. So this becomes a 1/4. I'll write it as e to the 2x. Multiplies the denominator, the coefficient by 1/4. Oh, I'm sorry, by 1/2. Because you have the 2 there, you have a 4 here. So you have x e to the 2x over 2 minus e to 2x over 4. And of course we need the integral of this one here also. X squared dx. That's easy. I just add 1 to the exponent. That gives me x to the 3rd over 3. And then you have the constant of integration. So we have x e to the 2x over 2 minus e to the 2x over 4 plus x to the 3rd over 3 plus the constant of integration. So that's your solution, the integral for the first one. Now for the second one, we have the natural log, we have the integral of the natural log of the 4th root of x dx. And we're going to use a formula that I've derived in another video. Just in case you missed that, here's the problem worked out. So you have the natural log of x dx. That's going to involve integration by parts. So the setup looks like this. You have the u equal to ln of x. dv is 1 dx, or just dx. du is 1 over x dx, derivative of ln of x. And then here, dv dx integrate, you get v equal to x. And then use the formula I just finished using in that first part of the video here. U dv equals to uv. U is ln of x, v is x, there's the product there. Then it's minus, started over here, u times v. I put the v first, x, and then u, ln of x. Then it's minus the integral of v, which is x, times du, which is 1 over x dx. There it is right here. And of course the x cancels out. I simply get 1 dx, and the integral of that is x. And then I have the constant of integration. So it comes out to x, ln of x, that is the integral of ln of x dx is x, ln of x minus x, plus the constant of integration. Now some instructors expect you to know this formula as part of the list of formulas that you learn or memorize or learn how to derive in case you need it. But in this case we're going to assume that you know that formula. So for something like this, this is going to equal to, remember this is fourth root of x is x to the 1. Same thing as x to the 1/4. So you can use the property of logs that allows you to bring this exponent as a coefficient. So this will be 1/4. The 1/4 comes out in front of the natural log, but then you can bring it outside the integral. So it's ln of x. So the answer to this integral here is simply 1/4 times the value of this integral here. So I just put it in parentheses, and this is just x, ln of x. You either just know it by memory, or you can derive it, as I did, or as I showed you a while ago. It's just minus x here, and then of course it's plus the constant of integration. That puts us out to the right here. And this would be the integral. Obviously, if this were a fifth root of x, you'd have the 1/5 out here, and this, of course, would still be the same, plus the constant. Thanks for watching. We'll see you next time.